Hello students, now we will discuss about on what factors resistance of a conductor depends. So let's start. Resistance of a conductor depends on three factors basically. First is length of conductor, second is area of cross section of conductor, and third is nature of material of the conductor and temperature. So if we talk about length of the conductor, resistance depends directly on the length of conductor. Means if length is doubled, resistance is also doubled. If length is tripled, resistance is also tripled, like this. And if we talk about area of cross section of the conductor, like this is the area of cross section of the conductor. If area of cross section is less, then resistance will be more, and if area is more, resistance will be less. This is the relationship between area of cross section of the conductor and the resistance. It depends inversely. Means if area is doubled, then resistance becomes half, and if area is made half, then resistance becomes double. And third is nature of the material. Students, there are lot of materials. We can say that this is good conductor and this is bad conductor. So depending on the internal construction or internal arrangement of electrons, term them conductors or insulators. So if we talk about silver, it is the best conductor, and if we talk about plastics, rubbers, these are the bad conductors of electricity, or you can say insulators. So students, we are now having two relations. R is directly proportional to L and R is proportional to 1 by A, means inversely proportional to area. If we combine these relations, we get R is proportional to L by A, and if we remove this proportionality constant, we have to put a constant. This constant rho, this rho is known as constant of proportionality, or you can say specific resistance or resistivity. There are three names of this symbol. This is constant of proportionality, specific resistance, or resistivity of the material. So if we calculate formula for this rho, then it will be R into A upon L. So this is the specific resistance of a material. And if we talk about unit of this resistivity, unit of resistance is ohm, area is in meter square, length is measured in meter, so unit of rho is ohm meter. This is the unit of resistivity. So students, this resistivity doesn't depend on the dimension of the conductor. Means if we increase length, if we decrease area, or any other cases, then resistivity of the material remains same, because it is the property of material. It doesn't change on the change in the dimension of the conductors. In the change in the dimension of conductor, resistance will change. And if we talk about if we take this formula, rho is equal to R into A upon L. If L, length of conductor, is 1 meter and area of cross section is 1 meter square, then rho is equal to R. So we can give definition of this resistivity. The resistivity of a material is defined as the resistance offered by the conductor of that material having unit length and unit area of cross section. So if we talk about resistivity of copper, then we can say that if we are having a conductor of copper material of 1 meter length and 1 meter area of cross section, then how much resistance is offered by that conductor is known as resistivity of that material. So resistivity is defined as resistance of the conductor whose length is 1 meter and area of cross section is 1 meter